Hi, welcome back to my YouTube channel. In today's video, we're going to continue from the previous video where we had to speak about different techniques of differentiation. In this particular video, we are going to focus on how we can apply some of those things that we've mentioned in the previous video. So let's just get started, get into it. Okay, so the first problem here is how to find the derivative. Derivative of this function. So derivative of this function, right? Now, so the first thing that you note about this function is what? This is what? Product of two functions, product of x cubed and sine 3x, okay? So we can simply remember how you determine whether it's going to be product rule or not is by substituting another variable for your functions, right? So we substitute u for x cubed, and when we substitute v for sine 3x, we try to make y as a simple function to look as simple as possible. So this turns out that what this will be u times what v, and this is how we know that what we are going to use product rule for this problem. Okay, I hope you kind of see the technique, a little bit of trick I'm using by first of all substituting value for your big function to make it look simple. That will now allow you to see clearer whether it will be product rule, quotient rule, chain rule, or whatever. Now, how do we find dy dx here? So y prime, because we're going to apply product rule, that would be u multiplied by what? Derivative of v plus v multiplied by derivative of u, which means we have to find the derivative of u. So we need to find what du dx is, and we also need to find what dv dx is. This is now our problem. This problem has now been narrowed down to just finding du dx and dv dx, and once we find those, we can just substitute back into this formula to get dy dx. Okay, now du dx, you can see everyone knows it's very easy. Du dx is just derivative of what? A polynomial, which will give us 3x raised to power 3 minus 1, 2. Now, if you're not familiar with this or you don't know how I got this, make sure you watch the first video in this series. In this playlist, you would see that in the first video we discussed this. Now, in the same vein, we need to find dv dx. Now, this is where I wanted to point you guys to. Now, we know that what v is what? Sine 3x. Now, to find dv dx, we have to use chain rule. Why do we use chain rule? Because we have nested function here. We have sine and we have 3x. So you can definitely substitute another variable for what? The inside of this function. We can see that we have an external part and an internal part. So because of this, we know it's going to be chain rule. And how do we use chain rule? We find the derivative of the external function, then we multiply it with the derivative of the internal function, right? So because we are going to use chain rule in between this product rule, we don't have to spend time to show all the workings for how we find the derivative of v with respect to x. We can just go ahead by understanding how to find chain rule, how to find derivatives using chain rule. We can quickly just go ahead and write the answer to this particular problem, because we know using chain rule we have to find the derivative of the outside function multiplied by the derivative of the inside function, and we continue to multiply by this derivative of the inside function until you reach the innermost function. Okay, so in this case, derivative of sine is definitely cosine. So we are going to multiply by derivative of sine, which is what? Cosine of whatever is inside the sine. So that's cosine of 3x. Now we have to multiply this by derivative of the inside function, or I said of the inside function, which is what? Derivative of 3x, which is 3. So this is how you know the answer to this is 3 cos 3x. Okay. Now, if you want to solve this as a standalone problem, let's say you want to solve this as a standalone problem, you have to substitute another variable for 3x. So let's say w. So let me just show you. That would have been v equal to sine w, where w is what? 3x. Now, we want to find derivative of this with respect to x, but we are following w, which means dv dx would give us, so this is just a side note, would be dv dw times dw dx. Now, when you notice dv dw will just be cosine w, and which is derivative of this with respect to w, then the x would give us 3. So that will give us 3 cosine w, where w is 3x. So it will give us the same thing, right? So now that's what I'm saying, that you don't have to, you know, use the primary definition of chain rule and you have to go through the solution again, because this is inside another problem. So you just want to quickly be able to find a way to get the derivative of of the function you're looking for, just like we did for u. We should be able to also find derivative of v. Unless v is a cumbersome function, then we have to use the steps to do that. Like when it is not easy to find the derivative of this, then you have to follow all these steps, right? All the steps here. But when it is easy, we can quickly do that. So this is how we got dv dx as 3 cosine 3x. Now we are back to solving dy dx, which is what, u x cubed multiplied by v prime. What is v prime? 3 cos 3x plus v, which is sine 3x, multiplied by u prime, which is 3x squared. So basically your answer is 3x cubed cos 3x. When we write this properly, we have this. So this gives us the solution to the first problem. Now let's look at the B part. So this was A. Now let's look at B. So in B, we have y equal to ln x over e raised to power 2x. Now again, when you look at this problem, somebody's already thinking about it. You can just pause the video here and tell me which rule we are going to use. All right, now the rule we are going to use here is going to be quotient rule. Why? Because we have this division. So all you need to do to be able, remember what I told you, is to substitute another variable for these functions. That will allow you to see it clearly. So if we substitute u for ln x and v for e raised to power 2x, so then we can clearly see that this is going to be quotient rule. And how do we find quotient rule? Y prime would be v u prime minus u v prime over v squared. So some people say v du minus u dv over v squared, and both of them are correct. So whichever one you're comfortable with. Now all we need to find is u prime and v prime. So we are back to finding the derivative of this and derivative of this. Now derivative of u with respect to x, we've treated this in the previous video. This is just 1 over the function here. Okay, it's just a simple function of x. Ln x is just 1 over x. Now derivative of v with respect to x, now you see again that we're going to have chain rule. Why do we have chain rule? Because we have one function, e raised to power 2x is just one function, but it's a nested function of two functions. Now how is the nested function of two functions? E raised to power 2x comprises of e, which is the exponential function, and the power, which is a function of x, which is 2x, right? So because we have this nested function, we know that what we are going to use chain rule. Okay, now how do we use chain rule? Is the derivative of the external function, which is e. The internal function is what? 2x. Okay, so we find the derivative of the external function multiplied by the derivative of the internal function. So derivative of e raised to power anything is going to be e raised to power that thing. So this is the derivative of the external, right? We now multiply this with the derivative of the internal. Derivative of 2x is going to be 2. So this is how at one stroke you can quickly find the derivative of e raised to power 2x using chain rule. And how did I recognize we have chain rule? Because the functions are nested together. Just one function, but we have two functions into one, which is exponential function here and also the polynomial 2x. All right, so we found d prime. Now we are ready to put all of this into y prime. So y prime, which is, don't forget, this is the same thing as what dy dx. So this would be v e raised to power 2x times u prime. What is u prime? 1 over x minus u, which is ln x, multiplied by v prime, which is e raised to power 2x, all over v squared, which is e raised to power 2x all squared. Now you should simplify this. In general, you don't leave it as it is. You try to simplify as much as you can. Now when you look at the numerator, you can quickly see that what So let's rewrite this one more time. We have e raised to the power 2x multiplied by 1 over x, so that is e raised to the power 2x over x minus 2 e raised to the power 2x ln x, everything divided by what? E raised to the power 4x, right? So using using indices, 2x times 2, so multiply the powers together, so you have 4x. Now, now we just need to simplify the numerator. So what is in how do we simplify that? You can take the LCM if you like, right, of the numerator. So that would give us x, okay? Then x into x is 1. So the first term will be e raised to the power 2x minus, and 1 into x is x. So multiply that with the numerator, then x. Now, all of this divide by what? E raised to the power 4x. Now, we can simplify this further as this. The x would now come to the denominator as this. Okay, so now that we have this, we can then factorize e raised to the power 2x out. I think it's common for the numerator. Just check, you can see that what e raised to the power 2x is common for the numerator. Then we have this, okay? Now, so now if you like, you can simplify e raised to the power, so you have e raised to the power 2x here, you also have e raised to the power 4x here. So you can simplify those, right? So just think about it. If I have e raised to the power 2x divided by e raised to the power 4x, this can be simplified using indices as 2x minus 4x, which will give me e raised to the power minus 2x, okay? Which is simple as 1 over e raised to the power 2x. So when you combine this with what we have here, so the answer would be 1 minus 2x ln x all over x e raised to the power 2x, okay? So this would be your final answer. So some of you are asking me, is this really necessary to simplify up to this point? In some cases it is, right? Just think about it. Let's say you have an objective problem, and this is part of the choices, but none of these steps is part of the choices. So what would you do? You would have to simplify first before you find the right answer, right? So most of you would want to leave your answer here, resist the urge of doing that, right? I mean, at this stage, you are expected to be able to simplify the expression to finalize what you have. Okay, now let's move to the next problem. So the next problem, let's see where it is e raised to the power 5x multiplied by 3x plus 1. So let's come here. So we have y equal to e raised to the power 5x multiplied by 3x plus 1. Okay. I hope, yeah, okay, that's correct. Now, again, what do you notice? Okay, I'll let you go first. Tell me which rule do you see? Now, the rule I will see, there are a couple of ways to solve this problem. I wouldn't say that there's just one way to look at it. But if once you become very good, you're going to solve it the way I'm about to solve this problem, okay? Now, so I could, after I solve it using this method, I could actually show you the other way to look at the same problem. Now, when I see this, I just basically see that there's product of two functions. This is the first one, and this is the second one. So I could easily substitute again u as what? E raised to the power 5x, and v as what? 3x plus 1. Okay, now you can see that what y becomes the product of u times v. That's how I know I'm going to use product rule to solve this problem. Okay, so what I need to find is u prime, which is just derivative of u with respect to x, and I think everyone now knows is what? Derivative of e, which is e raised to the power 5x, multiplied by derivative of the inside, which is 5, because we are going to use chain rule to solve that problem. And secondly, derivative of 3x plus 1, derivative of b with respect to x, don't forget this is dv dx. That would give us derivative of the first one is just 3, derivative of plus derivative of this constant, which is going to be 0. So it's just 3. Now we are ready to find the y dx. So the y dx, don't forget this is just the same as y prime, right? Y prime looks neat. That's why I usually use y prime and u prime and v prime. Okay. Now, what is y prime? It's just u v prime plus v u prime. So what is u? U is e raised to the power 5x times v prime, which is 3, plus v, which is 3x plus 1, times u prime, which is just 5 e raised to the power 5x. Now notice how I'm putting brackets around this to make it easier to see for the other person reading the work. Any other person reading the work should be able to identify what you're trying to and what you're computing here. And brackets usually help us to compartmentalize the terms that we have in the expression. So we have this plus, what about this? This multiplied by this, right? So it's just, so you can, if you like, so what I generally do is I'll bring the one that is a single term to the front, and I'll multiply it with the one with two terms, right? So that would give us, so let's do, this times 3x will give us 15x e raised to the power 5x. Then 5 e raised to the power 5x times 1 would give us 5 e raised to the power 5x. And when you add this, you can see this and this are like terms. So when you add them together, you have 8 e raised to the power 5x plus 15x e raised to the power 5x. So this is how you solve that problem. Now, the other way to look at this is, say, the first thing that you do is you kind of simplify your function first. So you can multiply out this function first. So e raised to the power 5x times 3x, that will be 3x e raised to the power 5x plus e raised to the power 5x times 1, I will have e raised to the power 5x. Now I can find the derivative of this now. dy dx will just be derivative of this plus derivative of this. Now, what is derivative of this one, right? Now you notice that what you have product rule, right? The first, so before we go to the y dx, notice that what here we have product rule for this function. The first one is 3x, and the second one is e raised to the power 5x. So because we have product rule, so to solve this problem, to solve the derivative of this one, so this is basically, let me just write it, the derivative of this function plus the derivative of this one. Okay. All right. Now we just said this function is product rule, right? Where the first function, we can call this one u and we call this one v. So in that case, derivative of this would be, we leave u, we multiply it by the derivative of v, right? So I will say e raised to the power 5x prime, right? Plus, so that is, in dealing with this term, right? Plus, we leave the second term, multiply it by the derivative of the first term. Now, this is product rule. Now, you can see my notation can change a little bit, but I think everyone can understand what I'm trying to do, right? I use prime for derivative. So sometimes I use d dx, and all of those things, you should be conversant with them. You should be comfortable solving a problem in those in that manner. Okay. Now we are done with this. Plus the derivative of e raised to the power 5x. I think everyone knows this is now 5 e raised to the power 5x. Okay. Now in finishing this, 3x multiplied by derivative of e raised to the power 5x is 5 e raised to the power 5x again, plus e raised to the power 5x times derivative of 3x, which is just 3. Then plus we have the final term here, this. So when you look at this now, you have 15x e raised to the power 5x plus 3 e raised to the power 5x plus 5 e raised to the power 5x, which gives us 15x e raised to the power 5x plus 8 e raised to the power 5x, which is the same thing as the first method. You see, you can see that this method is a little bit trickier than the first one. This is why I like the first method, where when I see the function, I basically just use the product rule directly, right? Instead of simplifying the function first. All right, let's move to the last problem, which is derivative of x squared plus y squared equals 25. Okay. Now, we haven't talked about this explicitly, but this is going to be, there are two ways to solve this as well. Now, there's what we call an explicit function and implicit function. In this case, note that with this equation, y is a function of x, okay? That's why it's going to be an implicit function differentiation. Now, how do we find How do we solve this problem? So I can solve this problem directly using the implicit function way, or I can, there's another way, which is I'll first of all make y subject of formula in an explicit form, and then I'll now use this explicit function to find the derivative of y with respect to x. So let's look at both ways. Now, using implicit method, function differentiation, what do? I'll take the derivative of both sides. So all I'll do is just take the derivative of what? Both sides. Now, it turns out that what, because we are dealing with derivatives, derivative of the sum of two functions, which is sum of these two functions, would be equal to the sum of their derivatives. So I can separate them using these derivatives, right? So they will be equal. The derivative of the sum is same as the sum of the derivatives. So that is clear. And then derivative of 25, because this is constant, is going to be 0. Now, what is derivative of x squared with respect to x? It's just this the same function, right? The function is in terms of x, right? So we just have 2x. Now, what about the derivative of y squared with respect to x? Now we have to use what? Chain rule, because for us to find this derivative, we have to differentiate the function y squared first, right? So think about it as if I have, let's use another function, let's say z, where z is actually y squared, and y is a function of what? Y is a function of x. So let's just say y is a function of x, okay? So think about it, this is same thing as d dx of y squared, right? Okay, so we are just writing it in this form. Think about it this way. Now, derivative of this function with respect to z is, for us to get to x, we have to go through y, and then from y to x, right? Think about it that way. Now, so d dx of the z is same as what? Dz dx, right? And that will have to be dz dy multiplied by what? Dy dx, which is the chain rule. Okay, now notice that what? Dz dy is just derivative of y squared, which will give us 2y. Now, dy times dy dx, as you can see, right? Derivative of y with respect to x. So this is the same thing that's going to happen here. So anytime you're going to find, because we are using implicit function, anytime you have to find the derivative of a function that has to do with y, you first of all take the derivative of that function in terms of y first, which is 2y. Then you multiply it with what? Dy dx. Okay, which is exactly what has happened here, using looking at it as a chain rule. Okay, and then this will be equal to 0. So what you have to do next is make dy dx a better formula. Now, sometimes I would use this y prime because it looks cleaner this way. So in that case, 2y y prime would be equal to minus 2x. So I'll take this to the other side. So what will be left is for me to find y prime, which is minus 2x all over what? 2y. So in this case, your answer would be what? Minus x over y. Now notice that what? This solution, okay, notice that this solution offers you an answer in terms of x and y, not in terms of only x. That's because we are solving this using implicit differentiation. Now let's look at the other method that you can use to solve this problem. And in that particular method, we are going to have our answer only in terms of x. So this is the second method. And both of them are quite acceptable, basically. So here you can make y subject of formula, which means y will become square root of what? 25 minus x squared. Okay. Now, can you take the derivative of this? Yes, you can. But now you have to be careful, right? You have to use what? Chain rule, right? I would, because we have convolution of two functions here, so which is basically 1 over 2. So I'll prefer to write it this way. Now you have convolution of two functions, or rather not convolution, nested, two functions are nested together. The first one is the internal one, and this is the external one. So this is external, and this is what? Internal. So you know you have to use chain rule. So substitute another variable for the inside of this function. Okay. Now, y would become v raised to the power 1 over 2. So remember, you want to go to x through v, right? So dy dx would be dy dv times dv dx. Now, what is dy dv? So dy dv, you can see I'm trying to differentiate this function. Now, this is just a fractional power. It's just the same thing as how you differentiate polynomial. So you're going to have 1 over 2 here, v raised to the power 1 over 2 minus 1. We reduce the power by 1, and that will give us 1 over 2 v raised to the power 1 over 2. So you can simplify this. The intermediate step here is just writing v raised to the power minus 1 over 2, which is equivalent to this. Okay, so basically we have 1 over 2 square root of v as dy dv. And finally, we need to find dv dx. Now, what is dv dx? The differentiation of this with respect to x is just minus 2x. Okay, so therefore, dy dx is going to be dy dv, which is 1 over square root of 2, 1 over square root of 2, 1 over 2 root of v multiplied by 2x minus 2x. So that will give us, so 2 will cancel out, that will give us minus x over square root of v. Now, what is square root of v? Remember, what is v? V is what? V is what? Square root of v, remember, square root of v is actually y, right? But square root of v, v is actually, in terms of x, is square root of what? 25 minus x squared, which is actually minus x over y, if you notice, right? Because you can see from here, y equal to square root of v, which is something as what we have here. So in terms of x, you can actually write it explicitly as what? Minus x over square root of 25 minus x squared. So this is the other way to solve this problem. I hope this video was really helpful in terms of understanding how to differentiate this type of functions. And if you do like this video and it was really helpful for you, make sure you subscribe to the channel and like this video to help the growth of this channel so that other students like you can benefit from it. And then I would see you guys in the next video.